All right. Hello, CIS C157 students. I wanted to record another programming video tutorial for you to cover your week 6 programming assignment. So this week we are introducing all of you to the concepts of functions in programming. And functions are a fundamental part of almost all programming languages that really make code easier to read, easier to test, and easier to understand by segregating logic. So functions are a really important concept in programming, and we are going to walk through some examples of how to use functions to refactor or to rewrite a piece of code that works perfectly fine, but is written as one continuous block of code. So for your assignment this week, you're working on a shopping cart checkout calculator. To show you how to approach that assignment without giving away the exact answers, I'm going to demonstrate these concepts using a different scenario, and we're going to be working with a payroll calculator that a company might use to calculate an employee's pay stub. So let's take a look at the code that I have in Visual Studio Code already, and we'll walk through it here, and then we'll start working on refactoring or rewriting this. So the code that you see on the screen here works perfectly fine. It takes some user input that we can see right here. It does some math in the form of calculating different fields for a pay stub. And then finally, it prints out or displays the pay stub to the screen. So this will work perfectly fine if we run it. In fact, let's run it right now just so you can see what this piece of code looks like. So let's run this Python file. Maybe zoom in a little. All right, we'll run it again. So enter the employee's name. We'll say our employee is named Jane. Hours worked this week, let's say 30 hours this week. And then the hourly pay rate, let's say $30.72 an hour. We'll hit enter and then we can see we get our pay stub output with the employee name, the gross or the total pay, how much taxes are withheld based on the tax rate that we have defined, and then finally the net or the take-home pay. All right, so as you can see, the program runs perfectly fine for what it's supposed to do. We just want to make it a little more modular and easier to utilize in other use cases by introducing functions here. So let's go ahead and start fixing this by writing a new program. So in Visual Studio Code, I'm going to create a new file, and I'll call this one payrollrefactored.py. And I'm actually going to open these files side by side so we can see our original program that we're refactoring as we write the new refactored version. So let's go ahead and build this piece by piece. First, I'm going to set up my global variables at the top. Now, a global variable can be accessed anywhere in the script, and we're going to go ahead and use the first two values, the company name and the flat tax rate here, as our global variables for this program. So first, I'm going to put a comment because your assignment asks you to put specific comments for global and local variables. And I'll say global variables can be accessed anywhere in the program. Okay, and then we'll just define these. So I'll do company name equals stop the exploit LLC, and then tax rate equals 0.15. And that would be a percentage. So 15% tax rate is essentially what we are defining here. All right, now let's create our first function. So we have our global variables. Let's make our first function, and we're going to do this using the def keyword in Python. This first function's job will be to handle all of our user input logic. So when we're prompting the user for the employee named, hours work, hourly rate, we want to put all that logic in one function so it's all in one kind of easy to test or easy to read place. So first I'll type in def, and then I have to give my function a name, and I want this to be a descriptive name of what the function is doing, what action it's performing. So I will call this get employee input here. All right, and then we open a set of parentheses, and in a function, if we have parameters that we want to pass into the function, basically variables or values that we want the function to work with or have access to, we would put them inside of these parentheses. But for this user input one, it will not have any parameters. So I'll leave that blank, and I'll put a colon, and then I'll press enter, and you can see all the logic for the function will be indented after the colon, just like it would be in a for loop or an if statement. So let's go ahead and get all of these same pieces of information that we get in the main program. So for employee name, I'll just name that name inside of this function, and I'll do equals input, enter the employee's name, colon space. Okay. And in fact, I'm just going to copy in the other two so I don't have to worry about rewriting them or making typos or anything. And I'll make sure that they are indented. And then I'm actually going to change some of these too, and we'll make this rate. So you can see I have much more descriptive, or the original script has this descriptive variable name of like employee name right here, right? I'm calling mine just name, and the reason I'm doing that is that our function definition kind of already tells us that we're getting information about the employee. And so you can absolutely keep the same kind of descriptive variable names like that. But one of the benefits of a function is since we're putting all of similar logic in one place, sometimes your variable names can be a little bit shorter because the description of what's happening is kind of self-evident based on the function and the logic that's taking place within it. So that's another benefit of functions is sometimes you can have shorter or more to the point variable names since the user or the person reviewing the code or writing the code already knows kind of the logic that's supposed to be happening within this function versus just having a lot of input statements one after another kind of in the middle of your script or at the beginning of a script. It might be a little more confusing. The other thing I'm going to do here is I'm going to add a comment to specify that these are all local variables or input and then not available outside this function. And so that means if I try to print name, hours, or rate outside of this function or access them anywhere else, Python will give us an error saying that these variables are not defined because the scope is local to only within this function. And finally, we want to return these three values from the function so that we can use them elsewhere in our program. Now, Python is one of the kind of unique programming languages that makes it really easy for functions to return multiple values. A lot of other programming languages do not allow this type of behavior, and so a function can only return one value. And the way you would get around this in a programming language that has that restriction is rather than returning three separate variables, you would put these into a data structure that is just one variable. So maybe a list, right? So at the end of this, you could like return and then in a list, name, hours, rate. And so this is one kind of variable here that's being returned. But in Python, again, we don't have to do that. We can actually return multiple values. And so I'm just going to return name, and you separate the values you want to return with a comma. So name, hours, rate, all those values there. So they're all going to be returned from this function, and then we can take them and use them in the additional functions we're going to write to finish this program. Okay, so we have our first function there. Let's go ahead and work on the next two functions that I want to write here. Now, your assignment only requires two functions total. I'm going to do a few more just so you get an idea for how we can use functions, but don't feel like you have to do exactly what I'm doing here in your assignment. You can kind of pick and choose two different functions that you want to write. All right, so let's go ahead and think about this. I'm going to write two functions. One is going to be called calculate gross pay. Okay, and then the other one is going to be to calculate the taxes. Let's do that. Calculate tax. Okay, so let's do our gross pay one first. And this one is really simple. We're just going to take this piece of code here, and we're going to copy it in and just return this. Return gross pay. All right, so let's look at our warnings here. Basically, these underlined yellow squigglies here. So it says hours work is not defined anywhere in our program, neither is hourly rate. Yep, that's true. We haven't defined those anywhere. And in fact, we are going to pass both of these values in as parameters for this function. And so I'm just going to take those two variable names, hours worked, comma, hourly rate, and pass those in as parameters so that our function has access to them. So when we call this function, we're going to need to supply these two values so that our function can perform the calculation and then return the gross pay to us. All right. And then for our last function to calculate taxes here, similar thing. So I'm going to do calculated deduction equals the gross amount times our tax rate. So for this function, you can see tax rate doesn't have a warning, and that's because tax rate is a global variable. So this demonstrates how global variables, our functions have access to them. But gross amount does not exist anywhere, and so this is another parameter that we're going to pass to our function, gross amount. And this value we're going to get from calculate gross pay. So we'll see that when we put this all together in the main body of our code. All right, and now we just want to return this value. So return calculated deduction. Okay, so very small modular functions here that just really perform a single piece of math here and return that to the main piece of code. So we have our calculate gross pay that takes in the hours and rate. That looks right. And you might be asking, why do we want to separate these into functions? There's a couple different reasons for it. One good one is for testing your code. If you wanted to do tests under various scenarios to make sure that gross pay and calculate deductions are returning values that are expected. If you have these in separate functions, you can write tests specifically that just call these functions with different values. Like maybe what happens if the user puts in a negative number for hours work, or the hourly rate is such a large number that it runs into issues calculating. Sometimes you want to test those edge cases, basically input that might not be expected or that might be out of the norm, to see how your function handles it. And then you can write further logic, which we'll go into in future weeks, about handling those exceptions or errors or edge cases that might come up. So that's one reason to do that. The other reason is that it just makes the code much easier to read, right? So if we put all of our individual kind of logic within its own functions, you'll see this when we write the main piece of the program. It's going to be kind of very easy to read and understand step by step, because most of the heavy lifting and the logic is separated in these functions. So the main part of our program is going to read just basically as descriptive instructions of what's happening without getting into the nitty-gritty details of any of that. So let's go ahead, and I want to do one final function since we're on a roll with writing functions here. If we look at the main program, we already handled taking the user input. We handled all of these kind of calculations here. The last piece of the main script that we started with just prints the pay stub. And so why don't we take all of this print logic here and write a function that's only job is to display the final output of the pay stub. So I'm going to define one more function, and I'll call this print pay stub. And then for the parameters, we're basically going to need all of these. So we'll need, and in fact, I'm just going to copy this whole thing in, and then we'll fix the errors as they come up. So let me make sure everything's indented first. Okay. So I've just copied over the code into its own function, and now we see all these squiggly lines. So we need to go ahead and basically define these as parameters to our function. So we'll just handle this kind of warning by warning. So we'll start off with employee name, and then we need gross pay, and then we need tax deduction, and then we need net pay. So we're going to pass in all four of those parameters to get this to print correctly. And then we get rid of all of our warnings. Everything looks good there. So the function takes four parameters, right? The name, the gross, the tax, and the net. And really all it's doing is taking those values and formatting them to print them out in a nice, easy to read way. So we actually do not need a return keyword for this function at all. So all of our other functions, we were returning values. That is not a requirement for functions. Functions do not need to return a value. You only need to return something if you need access to that value or variable elsewhere in your code. If your function is kind of a standalone one like this, where all it's doing is printing something and it's not performing any math or, creating any variables that you need access to later, you don't have to return anything. And in fact, that's the proper way to use what's known as like a void function in some other programming languages. No return statement there. Okay, so let's go ahead and put it all together now in the main part of our program. And so I'm going to just do a comment here just to kind of separate this. You don't have to do this in yours. Main program. I want this to take up kind of the full screen there. So we see a big separation in our code. This is our logic, all of these functions. This is the logic of our code. And then down here, this is going to be the main part of the program. So let's go ahead and print the same welcome message. Okay, so we have our welcome. And then let's go ahead and start using our functions now. So I'm going to comment these out step by step so we can see the logic here. So the first one is going to be get user input. And we have a function for that, right? We can go look back at that function, get employee input, and what do we have here? Well, we have a function that takes no parameters, but it returns a name, the hourly rate, or the hours worked, and the hourly rate there. And so what I want to do is I want to declare three variables, employee name, comma, hours worked, comma, hourly rate equals, and all three of these variables are going to equal our function, get employee input. And to call the function, again, you put the parentheses after, even if you're not passing in parameters. This is an indication to Python that we are working with a function here. So let me zoom out a little just so it's on one line. Right? And so if I go over hourly rate, I can see that my linter here is giving me type hints. So it's saying that this is a float, hours worked is a float, employee name is a string. So you can see up above. So it has access to this function and it understands what's being returned by this function because it can see the logic in my text editor. And so I get those extra useful type hints here for the different values that are being returned, the types. So that's it. That's getting the user input. Let's go on to step 2. After we get that user input, let's do some math. We'll say that. So here we're going to calculate gross and tax deduction. We'll do those two here. So we're going to say calculated gross equals, and then we're going to call our calculate gross pay. I'm going to open these up, and we're going to see here that it's going to tell us this needs parameters, right? So it needs the hours worked and the hourly rate. Well, we just got those two values up here from our input function. So that's the reason we wanted to return these so that we could use them in this function. So I'm going to pass in hours worked and then hourly rate. Right? And if you forget kind of the order it goes in most text editors, you can hover your mouse over the name of the function and it will give you the definition. So you can see, okay, I got to do hours worked first, then hourly rate. So you don't get the order wrong. You can also scroll back up and kind of read your function definition again to make sure that you're passing in these parameters in the right order. But that looks good to me. Now let's do calculated taxes here, and we're going to call our calculate tax function. And again, what does this one take? This one just takes the gross amount. Well, our gross amount was just returned previously. So this calculated gross, that's our gross amount. So we can pass that in, calculated gross. Perfect. That's all we have to do there. And then let's do a separate one for our final pay. So calculated final net pay. All right, and for this one, we're going to declare a variable. Whenever a function returns something, we want to usually declare a variable that the return value goes into. So calculated net equals, and then from here, we can just use the since we didn't write a specific function for this, right? We'll do a little bit of math here. Gross minus calculated taxes. Okay. So we're just using these two values. And to go along with the exercise, I could have written this into a function as well. I'll do that really quick just so we stick with the team. So calculate net equals, what do I need here? I need the gross and the taxes. So I need gross, taxes, and then I'll return gross minus taxes. Okay, just a quick little function there to calculate the net pay. And then we can stick with our idea here of only using functions. So now calculated net is going to be calculate net, the function, whoops, calculate net. And I'm going to pass in the gross, which is my calculated, and then my calculated taxes. Okay, so again, that quick one I wrote, it just takes in the gross amount and the total taxes, and it returns the difference between those two. And so that's what I'm passing in here. I'm passing in calculated gross, which we got from our calculate gross function, and then calculated taxes, which we got from our calculate tax function. And then finally, we're going to print the pay stub. So print the pay stub. And for this one, we're just going, we don't have to set anything equal because our print pay stub function does not return anything. So we can just call it directly. And to do that, we just type the function name. So print pay stub, parentheses, and it will remind us here that we need our gross pay. Sorry, we need the employee name, then the gross pay, then the tax deduction, and then the net pay. So for us, that's going to be employee name. That's the variable we have up here. We need the, what's next? Gross pay. So that's going to be our calculated gross. And then we need our tax deduction, which is our calculated taxes. And finally, we need the net pay, which is our calculated net. All of those values there. This is just formatting. You don't need to do this, but you can format your code. And if your function parameters are really long and spanning multiple lines, you can always format them like this to where you have them line by line. Makes it easier to read sometimes, but not required. All right, and that's it. So if we just look at the main part of our program, forget about the functions for right now. This is our program. And in my opinion, if you didn't know about any of the logic and you were looking at this program for the first time and trying to figure out what is this program doing, this is much easier to understand at a glance what the intention of the program is than looking at this. And the reason is, if you look at this one piece of code, you're immediately hit with all of the logic. So you see specific pieces of input that are coming in, and you're kind of reading the prompt of what we're asking the user. You see some math being calculated, right? So you might get a little distracted by that, saying, okay, what is this? Tax deduction, gross pay, what's gross pay? Okay, I'll look here. Got it. Hours worked times hourly rate. So you're spending a lot of time just kind of in your head looking at the math. And then we see the final print statement. We're saying, okay, what are we printing here? Okay, we have the employee name. Then it looks like we're printing gross pay and it has some formatting and then tax deduction formatting, right? And so this program's not very complicated. So you might look at this and say, hey, it's really easy to understand. But just imagine this is a much larger program that does a lot more things. And so it can take some time to read through. Whereas if we look at this one, well, this one looks like we are getting user input. Then it looks like we're calculating the gross pay and the taxes. Then it looks like we're calculating the final pay, and then we're printing the pay stub. We don't care about the logic right now when we're trying to understand what the program does as a whole. The math doesn't matter to us right now at this stage when we're trying to understand just really quickly, what does this program do? And then when we're interested in the logic, we can just go back to one of these functions. So I'm really curious of calculate tax. I want to know what's actually happening. Well, you can scroll to the portion of the code that does that. And then again, you can only look at this one. So within calculated tax, we have a very narrow scope here. We're focused on one thing, and we can just start to understand what this one function is doing. Once we're good with that, it makes sense. We can go back. Okay, I understand taxes. Let's look at calculate net. What's that one doing? And we can go back and just look at that one piece of code. So this makes code, again, reviewing easier. In my opinion, it's much easier to read too, because it limits the scope, or basically what you have to hold in your brain at any given time, to individual discrete tasks that are defined by these functions here. But all the logic's still there, right? All the nitty-gritty logic that exists in this main one still exists in the code. We've just kind of put it off to the side, or a different section of our code, for the complicated logical stuff. And then we've left the main part of our program, the high-level view of what's happening, much simpler and much easier to understand at a glance. So let's go ahead and run this now and make sure that this works, right? So I'm going to run this one. Let me open my terminal. Okay. And then let's run our new one, our refactored one. I'm going to scroll up and scroll in. So let's put in Jane. Again, I think Jane worked 30 hours, and then I forgot 30.72 or something. And we have the pay stub. Okay. Let's run our original one. I want to do Python, and this one is, where is this in? This is in week 6 and payroll.py. So we have Jane, 30, 30, 72. There are my results. Now I'll run the new one just to make sure that we didn't mess up the math, right? This is something I recommend that you do when you are writing your assignment, to make sure that in refactoring, you didn't change any of the desired output, any of the math. Everything is still working as intended here. Okay, so we'll do Jane, same input here, 30 and then 30, 72. All right, so real quick, I have 921.60, 138.24, 921.60, 138.24, and then 783.36 is the take home. Yep, so those look correct. And so basically I ran both programs, the original up here, and I got this output, and then I ran a refactored version, and I got what looks to be identical output, which is ideal. That's what we were trying to do. We weren't trying to rewrite any logic or change the way the program functioned. We wanted to keep all of that the same. We just wanted to make it more modular by introducing functions, which it looks like we were successful at. Okay. So when you are tackling your individual assignment, you'll be doing exactly what we just did here, but for the shopping cart, right? The checkout calculator instead, and you won't have to write as many functions as I did. So I think, what did I write? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 different functions here. I put everything into a function that was possible. You don't have to do that. Your assignment has specific requirements of how many functions you need to make, and then it has specific requirements for defining and using global variables, as well as defining and using local variables, which if you make functions, you'll automatically kind of get your local variables there. You just have to add a comment to point out which are which, right? So we know that you understand the difference and how you would use a global and a local variable. So it's up to you as you go through the assignment and the code that was supplied in your specific assignment. You can look through it and just ask yourself, what 2 things do I want to turn into a function here? And you can pick and choose. There's no right or wrong answer necessarily. So whatever you're more comfortable with. And then make sure that you are understanding kind of how these functions are written, or the syntax, which again, you can read more about in your Cisco Net Academy textbook. But the key takeaways are functions always start with this def, DEF for define keyword. And then if you want to use values in your function after you're done with your function, make sure you're using this return keyword to return that value there. And I already talked about the comments for a local and global variable. Oh, and you also want to make sure at least one of your functions is accepting arguments like these, or parameters. So one of them can be like this user input where there's no parameters supplied, but at least one of them has to take in parameters. So make sure that when you're choosing what you want to write into functions, you're picking something that takes parameters and then returns a result. Do not forget to take a screenshot of your working output in the console. So in my example, I would just take a screenshot basically of this right here. After my program runs, the user input 2. And then, as always, the source code, I don't need the original one, but your refactored code, you have to copy the whole thing, all of it, right? Copy it and then put that into a text file, a Word document. If you use a PDF, make sure that it is a PDF where I can copy paste the text out of. A few of you have submitted PDFs which are just screenshots, so you can't copy anything out of them. So if you're going to do PDF, make sure that afterwards you check, can I highlight the text in the PDF and copy it? And again, the reason that's important is I need to run your programs to make sure that they're functioning properly. And I can't invest the time to rewrite everyone's code based on a screenshot. So it's very important that you paste in your actual source code so I can copy paste it and run it myself. All right. As always, if you have any additional questions, feel free to reach out to me on Canvas or via email. More importantly, post about this in the discussion board so you can interact with your fellow classmates who are also working on the same assignment. And so as a reminder for your weekly discussion posts, it's acceptable to post questions or help other students who have questions for credit in those discussion posts. You don't only have to do the prompt, you can also post about your weekly programming assignments, and that will count for full credit. All right, well, thanks everyone for taking the time to learn about functions with me. I'm looking forward to reading all of your code, and I will see you next week.